My name is Milind Bhargava. Today I'll be talking about something that guys in this talk in real time. So bit about me. I have over 10 years experience in security, with core focus on threat intelligence, incident response, and digital analytics. And essentially, how to use STOR and build data and incident response together. So let's start with what is STOR or the end router. So when you visualize and explain what is that Tor means, as a lot of people don't really understand the onion component of it, I'll take a picture of the slide onion and we'll concentrate simple slide to explain what it looks like. Say you're a normal user. First, you access the Tor network, you'll use something called the Tor browser. After using Tor browser, you'll go to what is called an antidote. That is the Tor browser automatically. That is the outer layer. Then if you go to a relay node that may be one or more than one number, which will be more circles within it, so different layers of security that they're going through. Finally, you exit the exit node, which is the last one, and that's when you come to the website. Now, the website can be onion.com, .ca, anything, based on what is that you found the field. But if you want to open any .onion website, you can only open if you're using the .com. So what is the whole point of this? There is an assumption that there is encrypted traffic. But whatever anybody sees from outside, they can't see anything that's happening within the network. And at the same time, the main selling point of this environment, as in whatever thing you're doing behind this, will not be visible to anyone. Well, it's not really true. But the first point for that, an article that was published by CSIN USA, talking about malicious cyber activity that is originating from Tor. This is an article that released on the 1st of July 2020 to talk about how Tor is being used as a shield behind which attackers are hiding, so they can just go ahead and attack any entity. Full the importance that they will be competing in no one actually will gain from them. Well, that is true. You're seeing activity still coming from Tor. Now, what is the relation between Tor and IAM? From the background, I have worked in incident response for many years. And if you're worked in incident response in general, you'll also notice that a lot of times managing the contacts and communicating over Tor. As part of that, it may be beacon traffic, it may just be data exfiltration, infiltration in some cases, if they're just using optional traffic. At the same time, victim organizations are uniform and not blocking traffic or steady or destined to Tor. Like when you go through firewall traffic logs, like when you see the logs, you actually see that there is traffic incoming from Tor and going to Tor. And these are lists of non-Tor IDs and so on that are actually published, which you can add to a style blacklist and have things automatically blocked. The third point is that the third to the second point, all of the IP lists sort of Tor racing nodes and so on, which are published lists. These are things you can easily pick up from any blacklist, add to your firewall, and automatically block any traffic incoming or outgoing Tor. While this cannot block the entire thread, you've at least chopped off certain sections that cannot be easily traced back. And the third point, data exfiltration investigation starts to stop the problem. The moment you see any traffic leaving your network going to a Tor ID or a Tor URL, at that point the investigation is over.
And the third point for data exfiltration investigation generally starts and stops at all. The issue is that when you're going through all these firewall logs and you're seeing that the traffic for data exfiltration is going to a Tor IP or URL, generally you can't go beyond that because at that point, how will you find out who it really is or where is that data going on? What is the activity happening behind? So to understand that part better and to understand what really happened, especially with a client for an instance that I was responding, I built a small lab infrastructure. As part of that lab, I was trying to understand for a particular client who got hit by ransomware or how the attackers actually got in. Because all of the IPs and everything else that we were seeing was specifically coming from Tor and going out to Tor. It's completely Tor, no other connection. My aim was to somehow identify the two patients here, especially between all of the Tor, and completely add an investigation. So as I set up a Tor node, I realized a few things. by default or by design, Tor doesn't log traffic, which is technically a good thing. At the same time, a lot of users are actually torrenting over Tor, which is troublesome for exit node owners. I got more issues from people claiming copyright infringement than I got from law enforcement. Generally, should have been the other way around, but that. The other thing was inconsistent data. This is not structured data that's going through, it is all kinds of data. So it actually took a good amount of effort to understand what is happening with regards to the data and set it up in a simpler way. At the same time, continually hammered by attacks from Tor and the internet. So there were other people behind Tor IPs who were attacking the Honeypot, as well as normal connections and so on that are also attacking the Honeypot. So, and as you can see in my little graph here, this is the authentication activity over a 24-hour period. The greens are the failures and the blue are the successes. So I ran a lot of cron jobs to get the data out because that was the most effective means that I could think of. But there were a lot of login failures, and each bar here represents 1 hour. So it's almost akin to an enterprise-grade system that is taking a beating as compared to what happened in the Tor node. Now, as part of the node, to get the data in a somewhat structured format, I set up a custom Honeypot script that was based sort of Gastoff and GHH. So I can get the data in a way that I can track the vulnerabilities that are going through, especially to understand how are these attacks happening. Like when our client got breached, the IP that was doing the attack was a Tor IP. So I wanted to learn more on how exactly this works. And I use Sumo Logic for the data analytics part because I realized this pretty quick that without a big data solution, this is too much data to just look at. So a little of background of the client that got hit. The client's internet-facing infrastructure, at least according to the client, was printers. They actually had printers that were accessible if you went to show access with their IPs. They said it's a feature. I still don't get the point. They had web servers, websites, and DMGs, which is standard. They had default Apache pages and the corresponding default solutions, including the README files, which were supposed to be deleted about a decade and a half ago, but they're still there. Firewalls, SCADA, and IoT devices. Now, when we did our scan with their public IPs, domains, and everything else out there, we found more things, specifically unpatched web servers, systems running Windows 2003, FTP servers without authentication, and best Linux embedded servers, specifically BusyBox. Now, if you're familiar with BusyBox, you'll notice that it's present in all IoT devices. It's an embedded Linux web server. What the attacker was able to do was use the harvested credentials they got from another domain controller that was running Server 2003, which was quite easy to hack at that point, and still is at this point. And they used the same credentials because they were the same IT admin credentials that had not been changed in a decade. At that point, you also have to wonder what was the client's password policy if passwords were not changed for a decade. And the attacker had used a Tor connection to perform the compromise and all of the malicious acts. So I did a quick search on Shodan just to see how many BusyBox devices are available. It's little over 2,000 at this point. So these are devices that definitely should be secure, especially if you're using hard-coded or really old credentials that you never really bother changing. Now, specifically for the client, what is it that we saw? Right. I saw a lot of attacks, specifically using wget commands to download scripts from, say, another compromised website or compromised server that may belong to something else, which might be a legitimate company or illegitimate, and how it goes, and then running these scripts directly on the machine. So this query, for example, will download the script, then change the permission to executable, and then execute the script, and then so on. And towards the end, they will launch a telnet session to take control of the devices. So I ran a search earlier this year when the activity was really peaking. In the 90-day time period for this search that was run, the activity actually went up. And I've been noticing this a lot, especially thanks to COVID. Since a lot more people are actually working from home, certain kinds of activities are actually increasing. I'll show you more on what kind specifically. So I took the same commands that happened on the client infrastructure, and put that against the honeypot that I'm running. So I could actually see there were 21 unique IPs in the 30-day period, almost like last 30 days. 21 unique IPs that were hosting the malicious scripts. These were with popular cloud virtual storage or virtual server providers and so on. And in some cases, they actually belonged to legitimate companies that were compromised, I guess, at one point. There were 53 Tor IPs pushing the scripts. That means at the time that I was running the node, in my case, I was an exit node, which is how I can see all of this traffic. I had 53 different relay nodes who were sending me this information. And of the total targets, since I'm also the exit node and I could actually see who was getting attacked, so 4,036 unique targets. Now the count that shows, right, the count that shows here is for how many times I saw this specific command run. So this specific attack string or command ran 336 times. The next one ran 259 times. I'm not entirely sure on why certain commands were higher in numbers, certain lower. My best guess on that part is that at one point of time, the attacker was having good success with one set of IPs or one set of IOCs, and then they got caught, so it started moving to the next batch. So I guess the first batch had the best success rate, and then slowly got worse as time went on. Now, in this, do you think it could have been prevented? BusyBox IoT was compromised as it was externally accessible. In the client's case, this device had no reason to be externally accessible. The client also did not actually go through a firewall review or any other thing, so there were too many things missing in that case. The credentials that were harvested from the domain controller were reused throughout the environment. Like I mentioned, they had some admin passwords that were not changed for a decade. Just imagine, the password policy probably has not even changed in a decade, no matter what the client may claim. And the bad guy used Tor connection to perform the compromise and all of the malicious acts. So as far as we are concerned, either the Tor project people had us, or the client, or someone who's controlling all of the Tor nodes is the one doing all the hacking. In these cases, it makes it very hard to identify what is the initial person who attacked us and what is the actual patient zero. The only thing we can do is from a firewall log is to understand on what happened first and try to work our way backwards to that. Even with all of the things identified, I'm still only able to get the traffic that's flowing through my node and not through the entire network, because there's no way my one node will have enough of a percentage bandwidth share for across all of the nodes that exist in the network. Now, I try to take all of the attacks that are coming in and use what is called YARN rules and Sigma rules to try and classify or categorize what are the attacks and specifically what is happening. Over the last 30 days, I had a good variety of attacks where about 50% were SQL injection. Over the last year, I had 97.4% of them being PHP injection. So even though PHP injection may have slowed down in the last 30 days, but overall throughout the year, at least this year, I've noticed that a lot of people like to do PHP injection. So I tried to dig deeper on what exactly is it that folks are trying to do, or what is going on in the background that's causing one side to be significantly higher as compared to the other sides. Now, other activities I've seen is things like directory traversal. So that could be used with tools like Directory Buster and so on as you're doing pen testing or trying to break in if somebody's doing it over Tor. There's a lot of web scanning, which is almost following the path of the cyber killing framework when you first go for recon and you go other steps step by step. And that's the same thing that I've been seeing as part of traffic as well, that most attackers will do recon first and then they'll do something else. So to an extent, this can be used to predict who's about to get attacked next, providing certain amount of scanning across certain amount of devices, network, and other things have already happened. So it can be used to predict attacks and so on. Also useful to understand what are the different methodology that people are using. Like one of the things I found was LDAP injection, and I've only used that when I'm doing red team assessments. So if you want to ever learn how somebody else is doing LDAP injection, either maliciously or potentially as part of a red team, this is a great way to pick up their commands without them ever finding out. Also, for blue teams, you can use this to improve your defenses once you figure out what other people are doing. So as part of this, I try to draw patterns from all those things that are going in. I saw remote code execution going all around. I saw SQL injection. And through all of these, I was trying to further classify things better into different categories. What I was able to convert that into was a live feed of sorts of all of the attacks. Now, in this case, this screenshot, I had initially planned to show a live dashboard, but I was worried about my internet dying or my audio dying, which already happened, so let's not risk both. So this is a live dashboard of live feed of different attacks filtered into categories. So I'm taking all the attacks as they're coming in on the left side with the live feed with different payloads that are on it. And then I'm filtering out the remote code execution, the SQL injections, and so on. And the objective here was to see if I can classify this in terms of what is a genuine attack that is happening versus what is someone playing around with a tool they found online, because that also happens a lot. And many times you'll also encounter script kiddies in general who are attacking random websites and servers. So it could also be those people. At the same time, with RCE and SQL injection, I was trying to identify if there's any campaign going on, like for phishing and so on. You hear a lot of campaigns that there's a malware campaign targeting such and such organization with phishing. My thought was, can this same theory be applied to actual attacks that are happening through Tor that people are using? So for that, I was able to convert this into, say, standard templates of attacks. The one that you see on the left for the PHP injection attack, majority of these are using one tool, as you can see here. That particular tool, I've actually noticed, is the most pirated tool available for web application scanning. And a lot of people are running it over Tor just to hide themselves better, but it still shows up. The one in the middle is like default or template-based cross-site stripping attacks. And on the right, interestingly, I found a lot more for SQL injection. So especially in SQL injection, if I've seen the name of a table, apart from things like information underscore schema, which is like saying that I'm using a default table name if you don't have a table name, in cases where I actually saw a non-default table name or non-default database name used, that's a clear indication that at that point, that particular database has been compromised, because how else would someone external figure out what's the name of a table or a database unless they've had some access to it and so on? So I could actually identify who got compromised. So at this point, I was thinking, how else, or rather, what else can I do on this? Or how can I identify what specific tools are being used apart from things that are obvious in the names? So with that, I found something very interesting. Actually found a successful PHP injection attack happen using a CMS specific attack. So I saw a script with a payload specifically that is mentioning a specific file called xattacker2.jpg. Now, if you're familiar with the tool xattacker, then this would make sense. What xattacker basically does is it's an automated tool for exploitation and so on, and it's mostly used by criminals and so on to attack sites. I've not seen anyone try a legitimate use of pen testing, although it might be applicable. So this tool will first try to find out what is the CMS that you have. You have WordPress, Joomla, and so on. Based on that, is then going to run a command to check the uh, say document root to try and upload shells. If there's any vulnerability in any of the plugins, the themes, or say in this case it is WordPress, and WordPress is outdated. And if it's outdated, then it's going to try and upload a file to it. So in this case, it's trying to upload it, contents of a pastebin link. So whenever you write pastebin.com slash raw slash whatever the file is, that will dump the exact data, but not if you do it without raw, it is just showing you the file in pastebin.com site and you're accessing the say full page with HTML tags and so on. Putting it raw, you get the raw data. So in this case, it is trying to download the files there. If it doesn't work for whatever reason, as a second check, it's going to check if inside WP admin there's shapes.php and it's going to try it again. After it's done this, it is now going to execute the contents of the text file. So in this case, this file, pastebin.com slash raw slash this name, opened as this text file. Immediately when it opens, you can see the name again. It is running a tool called xattacker version 1.5. It is trying to set the file to have execution privileges for 644. It is trying to move the uploaded file to the temp folder. It's trying to change the permissions for it as well. And if everything succeeds, it will say success uploaded. In this case, or rather this particular string that we're looking at, this was after the whole attack had taken place, which made me realize that there might be actually more tools that are doing the whole automation of attack, and a lot of people are using that combined with Tor to hide themselves much better. And this is the tool. It says it's a free website vulnerability scanner and auto exploiter. The essential use of the tool is either you can define one IP address or URL, or you give it a list of say 100 URLs. It's going to automatically try and exploit that for you, almost like the Autopod tool that used to exist a while ago. So based on all of this, I was trying to understand how I can map this back into something that makes more sense. So I decided to go with the MITRE ATT&CK framework. Based on all of the attacks that I've seen so far as part of this research and so on, for initial access, the most common I've seen is the exploitation of public-facing application. That may be the IoT devices, that may be the web servers, and so on. For execution, I've seen scripting and service execution, especially with the remote command execution. For persistence, I've seen access to the external remote services. For discovery, there's plenty of web scan regardless and so on. So that's the network service scanning, the peripheral device discovery, or remote system discovery. For command and control, I've seen a lot of traffic as well. So especially for things like Emotet, TrickBot, QuackBot, QBot, and a few others, if you've ever looked at the traffic, you will see that all of their outbound traffic or beacons is actually going through Tor. And through all of my systems, I actually pick those up. I was able to format them into much better looking systems as well. So through the same thing, we also had Persian proxy and sometimes a custom command and control protocol. And all around for the automated exfiltration, if there's say a cron job running that will push files out to a system hosted within Tor or on the Onion side, we'll see that. And then again, exfiltration over CNC. Now I took all of this and I was able to further map this into an automated dashboard. In this case, not showing live, just a screenshot, where I was able to attribute the threads based on the Yara rules and Sigma rules for them to qualify all of the traffic that's coming through, and then automatically map that to tell me what kind of thread it is. Like, for example, if I pick on number 21, as part of the kill chain, it is an action or objectives. The thread type, it was a Docker, and if it was a stealer, the name of the malware was Vulcanops. It was part of the deployment framework. Um, So that the primitive pair is the most likely one, and again, these are indicators based on the TTPs identified and mapped against the MITRE ATT&CK framework, and even within the MITRE database, there is a list of all of the groups and their TTPs and all the things they do and so on. So all the information is correlated against that, including things like malware was used for mini Python connect action and so on. All the things that were happening specifically with that system, with that activity, with whatever traffic picked up, automated and backed against the attack framework. So just by looking at this, now you can tell what are the different kind of activities that happen. The unit number 17 was quite common because since I'm looking at our traffic, it will come back as store traffic, so that's kind of on the obvious point. And same for 16 and 18 as well. The other ones, like for example, I saw where I C2 going around. And some of this, especially when it says just C2, in those cases, there's also correlation against whatever free OSET services is, and just so I can make, say, better sense of this to understand what really is happening. So all in all, I try to map all of the honeypot activity in four categories. The discovery, that's the web scanning, the initial access, once people break in as the first part, the execution would be remote code execution and so on, and then command and control. So discovery in about a 90-day period was about 359,000 plus events. Execution slightly more at 360,000 plus events. Initial access 2.5 million plus events. So based on all the traffic I analyzed, what came out to be was there's a few web scans, there's a few execution. Again, since I'm not seeing all of the traffic that is going through, I'm only seeing partial things come my way. But when it says initial access is 2.5 million, that's the initial attack that happened on these systems. And then the command and control. So if you notice in the command and control traffic, there's a huge spike here, and then it all just drops and it's slowly coming back kind of thing. I initially thought this might be related to Microsoft when they say that they took down Emoted and a few other botnets. Except that news came out around October 19th or 20th. I didn't see anything earlier, although there's a chance they were actually working on taking it down, and that's why overall the traffic dropped. But even through this, we could still track more CNC systems as they're going through. Now, you may be wondering, out of all of this, how much is automated activity and how much is, say, someone actually trying to break in? So, of all the activity or the attacks, say, in the last month, identified about 85.8% to be automated tools. It could be like the one we saw earlier for X attacker. It could be someone using any of the other third-party tools that are meant for automated scanning. It could be someone using even Armitage for that matter, where you can just click on a Hail Mary and let it try on its own on all the different attacks it needs to do. The differentiation I made for the actual exploits were things like, say, a remote code execution that was run specifically for an IP and only run a few times, just enough to break in and then stop, or something that didn't match any standard signatures. Now, overall in this, what was the, say, different kind of attacks on non-attack traffic? I saw a lot of, in the last 20 days, it was mostly attack traffic. In the last year, also mostly attack, but over the last 3 years, which is almost the length of which I've been running this, it's about 50-50. So the point here is, in attack traffic, this would be attack to systems, this would be, say, data exfiltration or infiltration, this would be specific attacks on, say, web scanning and all those things. The known attack is regular traffic that was either encrypted or something that could not be deciphered or something that was so unstructured that I couldn't make sense of it. So it just went in the non-attack category. It is interesting though that all the attacks that I picked up were actually not encrypted. All of the attack commands, as they were leaving the exit node, none of them were encrypted, which is how I was able to get granular details on every single command and system that was running as a result. So you're wondering at this point, how does this relate back to the IR I was on? With having all of this specific information and understanding exactly how is it that attacks are coming in, what is the exact attack pattern and strings that are followed, I was able to collect all of the different kind of attacks based on the applications in use by the clients for the IoT devices, for the printers which made them get off the network, and other devices that were exposed. And I was actually able to identify what was the correct attack time frame. The attack time frame that you're looking at was from the time the ransomware was deployed and then working our way backwards. The first attack that actually hit in the environment was also from Tor and happened 1.5 years. And we only had that was I was able to collect other kind of attacks that are coming from Tor IPs, including attacks that may not be coming from Tor IPs, and seeing the pattern matching between them to understand better on how to protect that client. And the lessons learned from that activity was actually quite useful in protecting other clients as well. The truth of the matter is, there is so much evidence and IOCs that are available from Tor if you know where to look. And by building a honeypot, I was able to look better on how to proactively protect clients from all the new threats and attacks that are happening. Like, for example, I talked about the MITRE injection. What if that is not something that's in use for legitimate activity? You can use that to learn how's the attack happening, what's specifically the attack doing, and how you can better protect your clients in general. Also, Tor is technically not a dead end anymore. The benefit of running a honeypot on Tor is, as opposed to a honeypot on your own, if you just run a honeypot to yourself, you're only seeing attacks that are coming to you. If you're running a honeypot on Tor, you're not only seeing the attacks coming on you, and that's quite a lot still, you're also seeing the attacks that are going on someone else. So it's almost like you're learning from somebody else's lessons on what not to do for security and what not to leave exposed. Overall, you can run predictive analytics. Like I mentioned for the cyber kill chain, you can actually see where the attackers are coming from in terms of what tools and what methodologies and TTPs they're using, not specifically the locations. But you can see what they're doing, say, for web scan first, and then what they do next. And based on that, you can predict when somebody's about to get attacked or how bad the attack might be. Or if you see a lot of web scanning happening from Tor IPs to a particular IP or, say, domain that belongs to a client or even to your own network, if you're seeing a lot of web scanning activity from Tor IPs, Guaranteed somebody's probing around to find out if there's something worth exploiting, and then they will definitely go out and find that. So if you get to all of this, the possibility that exists for enhancement of threat hunting activities, actively acquiring more threat intel information, or just in general being better prepared for IRs, because now you know how to block things better, that definitely works out. So that's it for my presentation. Any questions? Matt, what do you mean by protecting yourself by using Tor? I think if you're on a Tor browser. Oh, I generally won't recommend on playing on Tor. As part of these activities, I've actually seen other people using Tor to exploit other people who are currently using Tor and get out of their browsers. I believe not using Tor from home is best. So my recommendation, if you need to browse Tor, get hold of a server you can rent out like a VPS and run Tor from there. So in case something is compromised, you just add a VPS and you can just delete it and move on. So some people like to use Tails from home as a VM. They also forget that the entry node at that point can still track their IP address because if they're using Tails, technically your home IP is still getting broadcast.